Hello and welcome back to the DIY Gamer Lessons. So let's review where we are. We have ourselves a ship moving around the screen. We have walls being drawn from right to left and they come towards it of varying height, of course, and we have to be able to dodge those things, hence the name dodge. And of course, we now need to know whether or not we've hit a wall, because every time I hit a wall, let's see what happens. If I hit a wall, nothing happens. And of course, we need to know when something happens so that we can tell the user, or you, the game player, that you've had a collision. Maybe it's game over. Maybe it's watch out, you've just lost a life, whatever it is. So we're going to set ourselves two major tasks. The first one is detect collisions. Very important. Have we hit a wall? And then once we've detected collisions, what do we do then? We then give ourselves some basic feedback to say, hey, you've hit a wall, just so you know. So in this case, if we look at our gamer, what can we use? Well, we know about serial printing, so we're going to print a message to serial. So give ourselves some feedback. One, print to serial. And two, what else do we have over here? Well, we've got this LED that flashes every time we upload some code. Why don't we use that? Turn on the LED. Perfect. The first thing that we're going to do is we're going to review our existing code, see how the logic works, and see where the best place might be to actually do some collision detection. While we're doing that, we'll probably do a little bit of housekeeping, do a little bit of organizing of the code. So at the start, of course, we remind the code that we use in the gamer library. We, of course, have all of our variables. Then we have our setup function where we connect to the gamer library and create a connection to the serial port as well. We then, of course, start the main loop. And in that, we first clear the screen. We then do all this wall-related stuff, check to see if there's a new wall. If there is, we draw it in or we create it. We then draw the wall to the screen. And then we read the switches and constrain to screen so we know how the user inputs are being handled. And then we draw the ship to screen based on the new positions from the user inputs. Then we update the display, and then we delay for a moment before we repeat the whole thing. Now, you see how we've got this function, the read switches and constrain to screen, and of course the draw ship to screen functions. Why don't we take this entire wall, all these wall tasks, and put them into their own function and call that function handle walls. So I've just cut that, all that code right out. So it makes it much cleaner, and I'm going to put it below our loop function. So if I click on the little curly bracket there, you can see where the end of the loop function is. Create this new function that's called handle walls, and then paste all that wall stuff in there. And now if I upload the code, let's see, it should do exactly the same thing as it did, except now that our loop is much more organized. It'll be easier to review. Okay, it launches, and yeah, let's have a look. Is there a wall? Yeah, here comes a wall. I can still move around. Everything's fine, and it still doesn't tell me when I have a collision. Perfect. That's where we want it to be. So now that we've done a little bit of housekeeping, let's think about the logic of that. First, we clear the screen. Then we handle the walls, which means draw the wall into the display. So first we clear the display, then we draw the pixels into the display where the wall is, and then we read the switches and draw the ship. So between the ship and the walls, what we're trying to understand is, are there collisions between our ship and our walls? And what is a collision? A collision is the ship wants to basically be in the exact same pixel location as the wall is. So the good news is we can use our display to tell us, the display array, to tell us whether or not we have made a collision. If a pixel is on where I'm about to draw my ship, then there's going to be a collision. So the way that we handle that is, first of all, we it clears the screen and then it draws the wall in, which means we need to let it draw the walls in so we can check for that collision. Then we're going to say if our gamer.display, and we're going to say ship X and ship Y, because remember that's that one point of the ship, is equal to 1. And what I'm saying here is if that pixel is already equal to 1, then I think we may have a little collision. So if that happens, then I'm going to do something. I'm going to say serial.println collision. Boom. That's all I'm doing. Just one pixel of the 3 pixels of the ship. I'm testing this out. Let's see if it works. So I upload that. And then of course I'm going to have to turn on my serial monitor as soon as I've finished uploading. Upload complete, turn on the serial monitor, and let's have a look. Okay, it started. I'm going to move my thing around. Oh, let's see if there's a collision. Collision, and we get the text tells us there's a collision. If I move into the right position, there's another collision, keeps happening every time that pixel right over there, the corner pixel, gets hit by the wall. Perfect. So we know the collision detection works. But of course, the ship isn't just one pixel, it's made up of 3 pixels. And I'm going to be an incredibly lazy person and review down at the bottom. Remember where we said draw the ship to screen, so we draw those 3 pixels in. I'm just going to copy those 3 lines of code and put them up here where I'm busy checking to see whether or not there's already a pixel drawn there. So, have a look at the difference here. In this code I just copied, I'm setting the gamer display equal to 1, and in the other one, I'm checking to see if it's equal to 1. When you're setting something, you use a single equal to. So, the left side of the single equal to is what I'm setting to the right side of the equal to. So, gamer display, this X and Y position is equal to 1. But if I'm saying double equal to, there's 2 equal to signs, I'm saying is the left side equal to the right side. If it is equal to, then it returns what's essentially a true value. It says, yes, it is definitely equal on both sides, or no, false, it is not. So, when I say if gamer.display ship X, ship Y is double equal to 1, it's returning true. It's saying this is true, so then do that statement, which is the serial print statement, okay? If it wasn't true, it would just skip that statement and go straight to the next line of code. So I'm now going to copy and paste this 2 times. 2. There it is. And I'm going to copy in specifically these 2 bits because that's what I want. Those are the only ones I still need to add, which is ship X and ship Y minus 1 and ship X plus 1 and ship Y. There it is. I can delete those now, so I've used them as reference. Perfect. So now let's upload that and let's see if that works. It's uploading. And as soon as it's uploaded, I can open up the serial monitor and I should now see whenever I hit any pixel with a wall, look at that, 3 collisions. Why? Because there's 1, 2, 3 pixels that make up the ship. That makes total sense. I'm thrilled. So, the next thing we're going to do is actually start using the LED instead, because obviously as the person playing the game, I can't read the serial monitor the whole time. I need to see something on the gamer itself. And we've got that little LED that flashes whenever we reprogram it. Let's use that LED. And so what we're going to do is say, instead of serial print line collision, what we're going to do is say something else. How do I know what that something else is? Well, I'm going to look at the cheat sheet. We know the cheat sheet. We remember the cheat sheet. Let's have a look here. On the cheat sheet, it says void setLED. So there's a function called setLED, gamer.setLED, true or false. So what we're going to do is say gamer.setLED, true. And I'm going to do that for each of them. There it is. Copy, paste, upload that. So now we're no longer using the serial monitor. We're just using the LED. Starts off, as you'll see now. The LED is off. And now I am playing the game. Oh, I skipped that one. I'm safe. I hit that and boom, LED goes on, stays on because of course nowhere in the code are we telling it to turn off. That's important. So we know that the game is over. There's no point in carrying on playing. It's all over for us. Brilliant. So now that we've managed to detect collisions, we've been able to set the LED or tell ourselves with the serial monitor, we now understand whether or not we want to do something with that information. And in order to do something with that information, we have to tell the program whether or not the game is over. And that's what we're going to do next. Join us next lesson for helping the game to understand whether it's game over or not.